Hello students, this is teacher Walter back again. We are still dealing with mathematics and we are dealing with unit 1 complex number, which is a unit 1 from senior 6, and we are dealing with today polynomial in the set of complex number. As you remember, if you have followed our 7th video on our website, you can visit it always, or you can go to our TV channel as you follow back the last lessons that we have seen so far. This is lesson number 7, which is about polynomials in the set of complex numbers. If you have not followed us last time, you can go back to visit our website and you get the 7th lesson, which was about the equations in the set of complex numbers. So we are now dealing with polynomials in the set of complex numbers. As you know, we normally deal with them in the set of real numbers. We have the polynomials where we have been having always the two variables, where we have now the independent variable and the dependent variable. So here also we have polynomials in the set of complex numbers where the unknown or the variable will always be z, which is a complex number. So here, students, we shall have the general format of a polynomial. The general format of a polynomial in C. This will be of the form P of z, which will be equal to an z power n plus an minus 1 zn minus 1. We go on decreasingly, the power will be decreasing on both the coefficient and on both the unknown or variable z, where we shall have now finally a1, it will keep on decreasing until we reach to a1 z power 1 plus finally a0 z power 0, which will always be equal to 1. Students, here we shall have that an minus 1, as we go on up to a1 and a0 finally, these are called coefficients. These are coefficients which might be also complex coefficients. They are coefficients, they might be real coefficients or they might be also complex coefficients. And here we shall have z, which will be any complex number. This n will be any complex number. So we might have different questions about these polynomials, where we can have to factorize them. After factorizing them, we can even solve some equations about them. We are used to factorize polynomials in different ways, and all those ways will be used here in the set of complex numbers, as they are even used in the set of real numbers. Students, let's have an example of a polynomial which is of this form, and we shall have to factorize it, and we shall even have to solve, and then we shall see how we deal with all of this. And then students, but always the general format of a polynomial in C will always be of this form, where these are coefficient and these are the unknowns. Let's have an example. So dear students, we have here an example. We have been given a polynomial P of z, which is equal to 3z squared power 4 minus 5z cubed plus 5z squared minus 5z plus 2. And we are asked to factorize P of z, and later on, after factorizing, we have to solve for z, which means that z is the unknown we have to solve for, and it is a variable. And then it is called a dependent variable, because it is an independent variable which is not depending on P, but P depends on Z. So later on we have now to solve for Z, which is P of Z, which is equal to 0, and find Z. So ladies and gentlemen, how do we now solve this? We must look at which factors of 2 which must be giving us 0. So we have the factors of 2. Those factors of 2, they are in the set of plus or minus 1 and plus or minus 2. One of these can be a solution, as well as you can get many other solutions. So students, what do? We now find P of 1. As we can go for P of -1, we later on find P of 2 and P of -2 until we find the 0 of the equation. So P of 1 will be giving us what? We shall have 3, 1 power 4, minus 5, 1 power 3. This means that Z equals to 1. Of course, that's why I'm replacing it by 1. Z, 5 plus 1, again, power 2, minus 5, 1 power 1, of course, plus 2. And we are going to see whether this gives us 0. So here we shall have 3 times 1, which is always 3. We have 5 times 1, which is always 5, -5, plus 5. And here we have -5 plus 2. So we are still looking whether it can be 0. So later on we shall see that this 5 we go with this one, and we shall have that this is 3 plus 2, which is also 5, minus 5, and we get 0. What does it mean? This means that as we have got 0, this means that Z minus 1 is a factor. This is a factor over P of Z. So what does it mean? It means that Z, which is equal to 1, is a 0 of the polynomial here, because if we replace in the P1, we get now 0, which means that it is a 0, and after getting that it's a 0, Z minus 1 is a factor of the polynomial. And then we are going to use synthetic division to find the other factors of P of Z later on. So, lovely students, we have seen that Z minus 1 is a factor of the polynomial P of Z, which is equal to 3Z power 4 minus 5Z cubed plus 5Z squared minus 5Z plus 2. So, using the synthetic division that we are all used for, we are going to have now this. We are going to have here the coefficient first. We have 3. The first coefficient is 3. The second is -5. The third is 5. The next one is -5, and the independent coefficient is 2 here. So, and we have to put here this Z, which is equal to 1, which was the 0 of the polynomial. Now, you remember that we bring down this 3. Bring down this 3, we have, student, to take 3 times 1. 3 times 1, which gives us 3. -5 plus 3, we get -2. -2 times 1, we get -2. 5, -2, we get 3. 3 times 1, we again get 3. And -5 plus 3, we get -2. -2 times 1, we get -2. And -2, we get 0. And that's why, because we've got 0 here, it means that it is obviously a factor. And ladies and gentlemen, if you have seen that this is 0, it means that P of Z equals to Z minus 1, and we like the remainder. As you know, the remainder is from 3 here, but the power will no longer be 4. It will be decreasing by 1, because here we have taken another Z, and we have another 0 here, which means that the next factors will start by 3Z power 3. Everyone understand? Minus 2Z squared now, plus 3Z minus 2. The powers have to go decreasingly up to 0 here. And then these are the factors. Ladies and gentlemen, when we reach here, we only have to factorize this. How do we factorize this? We go on and see that Z minus 1 factor what again now? When we reach here, ladies and gentlemen, we need to put together, to combine the like terms that can have some factors. You can see here we have 3Z cubed and 3Z here. They can be of the same factor. The factor here, which will be 3Z. If I put 3Z out, the remainder here will be, ladies and gentlemen, Z squared. Because if I multiply by 3Z, I will get 3Z cubed. And then with here, I will now get plus 1. And if I combine these two also with the same coefficient, which is -2, I will have now -2 factor the remainder here, which would be z squared, and then this negative 2, with this negative 2 I also have plus 1 as the remainder, ladies and gentlemen. Now when we are still here, ladies and gentlemen, we go on up to here, from here we go there, and we shall see again that p of z should be equal to z minus 1 factor. Now this is a common factor here also. We factorize it. Factorizing this, we shall get now z squared plus 1 factor the remaining coefficients, which is 3z and negative 2. So it means that it is z squared plus 1 factor 3z negative 2. I think everyone can see it. And we are here now. Reaching here, ladies and gentlemen, we are already about at the end to factorize this polynomial, but we can see this is not factorized. This can be also factorized. So factorizing now, factorizing z squared plus 1, we get what? We shall see that this will be, we have to get the factor forms of these ones by getting the zeros of z plus 1. So if we equate it to 0, ladies and gentlemen, we shall see that the 0 will be here, z squared, which is equal to negative 1. And if it is equal to negative 1, we are all used to see that negative 1 equals to I squared. We are all used that I squared equals to negative 1. So ladies and gentlemen, we get now that z squared will be equal to I squared. So which means that z will be equal to plus or minus square root of I squared, and this finally will be equal to z, which is equal to plus or minus I, which means that we have two solutions which are I plus or minus I, and then we can see that the factor form of z plus 1, this have to be equal to z, because a is equal to 1, it's z minus I factor z plus I, ladies and gentlemen. This will be now the factor form of this one. Now, after all, we can get now the general factor form of pz. After getting that z squared plus 1 equals to z minus I times z plus I, we can now go back to here and put what this factor form in this one, replacing it by this one, and finally we get the factor form of pz. Let's see it. After factorizing pz at this level, we have seen it, and we have seen how we have reached to this level after factorizing z squared plus 1. We have seen that it is its factor form is z minus I factor z plus I. So if we insert this within here and replace this by that, we shall get that p of z will be equal to z minus 1 factor now this, which is or what we have there, z minus I factor z plus I factor now finally 3z minus 2, and this is the factor form. This is the general factor form. This is the general factor form of p of z. Here, ladies and gentlemen, we have already answered on the first question. We need to go back and answer the second question. This was question number A. Number B, we are asked to solve for z, p of z, which is equal to 0. Now, ladies and gentlemen, after finding the factor form, it's very easy to solve. We shall see now that if p of z equals to 0, it means that finally z minus 1 factor z minus I factor z plus I factor 3z minus 2, this must be equal to 0. Now, if this is 0, ladies and gentlemen, this will happen when? This will happen if and only if one of these factors equals to 0. And we shall have now, it is possible if and only if z equals to 1 or z equals to I for the second one. For the third one, it is all if z equals to negative I, and this can also happen if and only if z equals to 2 over 3, ladies and gentlemen. So here we have how many solutions? We have 1, 2, 3, 4 solutions. And that's why our polynomial was of order 4. The polynomial of order 4 should always have 4 solutions. And now reaching here, we have already solved for z, where some answers are real complex numbers, but others are complex numbers. You see here that they are all solutions because you are working in the set of complex numbers. That's why sometimes the variable equals to a complex number. So the solution, the set of solutions, ladies and gentlemen, will be equal to 1. We also have I, and we have negative I, and we finally have 2 over 3. These are the solution, ladies and gentlemen. At this level, we have been able to manage how to factorize a polynomial and how to find a solution of a given polynomial, which means that when they equate the polynomial to 0, we get an equation that we have to solve. It was this one, and we will be able to solve it after factorizing it, ladies and gentlemen. So this is what we was to have as a lesson today, and now I'm going to let you review with our homework, and now that homework we will do it and to help you to understand better this lesson. So let's have homework. Ladies and gentlemen, we have here an equation. You have to solve the equation z power 4 minus 1, which is equal to 0 in the set of complex numbers. And here, my dear students, if you find the following answer, you should know that you are right, and you will just say that you have done a good job. So if you find the solution, which is negative 1, 1, negative 1, 1, I, and negative I. If you find this solution, ladies and gentlemen, you should congratulate yourself that you have done a great job, and you will be okay. And now, ladies and gentlemen, for the second one, I have given you to factorize z power 4 minus 4 factor 1 plus I times z cubed plus 12i z squared minus 8i factor 1 plus I z minus 5. And I'm asking you to factorize that polynomial, and after factorizing it, then you have to solve for z and for p of z, which is equal to 0, which means that you get the solutions, ladies and gentlemen. And after that, but always remember one thing, you should always start by factorizing, and after finding the factors, ladies and gentlemen, there you have to solve. Then here, if you find a solution which is of this kind, if you find a solution which is, ladies and gentlemen, 1 I, 2 plus I, and 1 plus 2I. If you find this solution, ladies and gentlemen, it means that you will be alright, and you should congratulate yourself. Here you should tick and give yourself 5 marks, and here you should tick and give 5 marks to yourself. And if you get 7 out of 10, or if you get more than 7 out of 10, or you get 10 out of 10, 9 out of 10, 8 out of 10, you should clap for yourself. You should have done a great job, and you should have understood this lesson. If you get under 5, you should go back and revise our video and restart again and see how we've been doing it. Ladies and gentlemen, here we have learned polynomials in the set of complex numbers, where we have learned how to factorize them and how to solve an equation using the factor form that we have seen so far. So ladies and gentlemen, this was lesson number 8, and I'm inviting you to go back to our website www.ubumenyi.net. If you have not understood this lesson, or if you have not seen the previous lesson, and you will go back to this website and you will see the first videos which will help you to understand more the lesson. Or you can visit our YouTube channel, Ikaram TV, and you will be able to download all the videos that have been passing here so far. And you should not forget to subscribe as well as sharing, so that you can be able to share with others. Thank you very much. I love you. It's Walter. Thank you.